But notice that I basically rewrote the exact same program, but with the word int replaced with float. And the point that I wanted to make right here is this guy here. Float.parse. It behaves exactly like int.parse, except for it works with floats. If I were to have done left user value equals int.parse, the funny thing about this is this will work. And we'll get to that why this works in a moment. But I will lose the fractional point. Or, yeah, lose the fractional point in the form of a format exception. If instead I use float.parse, we are allowed to enter strings that contain decimal points. And as you see, we get the appropriate calculation performed here. So, yeah, I just wanted to point that out because there is a corresponding float.parse. Okay, what is the fractional point, just the decimal place? Yeah, the fractional value, or the word that I used before and can't remember, is anything that follows a decimal point, also known as the remainder. So, yeah, those are floats. Now we had a question. Why would you want to ever use a float or an integer over a float? And the answer is that all data types have limitations. Floats can only store values up to a specific, Jason, what's the word I'm looking for?
Specific size.
Well, a specific size, but a specific
Certain
amount
number of bytes that are...
Yeah, but a specific number of significant numbers. That was the word I was looking for.
Wow. Yes, precision. Is that the word you're looking for?
Yeah. The amount of significant numbers in what we can store in a float is limited. Unlike with integers, integers will, as long as you can stuff an integer value into an integer variable, and there are times when that's not the case, we'll talk about that later, but as long as you can do that, you will always get the same integer back. Integers will never lose precision. Floats, on the other hand, will.